morning dear student. Today we'll see the model number 2, differential equation of higher order. Linear differential equation of second and higher order with constant coefficient. We'll see the first topic here today. The linear differential equation are those in which the dependent variable and its derivative occurs only in the first degree and are not multiplied together. The general linear differential equation of the nth order of the form derivative of n of function y with respect to x plus p1 derivative of n minus 1 of y with respect to x plus p2 derivative of n minus 2 of y with respect to x plus so on Pn into y equal to phi of x, where this P1, P2, so on Pn where this P1, P2, so on Pn are nothing but what here? The function of x, as well as this phi of x is also what here? Function of x. But this P1, P2, so on Pn are constant is called linear differential equation of nth order with constant coefficient. Now we'll see the differential operator. So wherever we have d by dx, will replace capital D. D square y upon d square upon dx square will replace as capital D square. D cube upon dx cube will replace as d cube, capital D cube, so on, and d raised to n of dx raised to n can be replaced by dn. So this capital D, whatever is there, we called as it is a differential operator. So based on the order of your differential equations, we have to replace it. Now you just go back to equation number 1 and I will apply there this differential operator in equation number 1. So first term what we have in the equation number is d raised to n upon dy raised to n. So I will go back here, you just see this. So this part, only this part will replace as what here? D raised to n, and will keep this y as it is. Similarly this d raised to n minus 1 upon dx raised to n minus 1 will replace as capital D raised to n minus 1, and similarly here and the remaining term. So what happened, just see, capital D raised to n of y plus p1 into d raised to n minus 1 of y plus p2 into d raised to n minus 2 of y plus so on plus pn of y is equal to phi of x. So here you can see that the y is common for all the terms. So I will take it common. What left here? Only d raised to n is left. Then p1 into d raised to n minus 1 is left plus p2 into d raised to n minus 2 plus so on, and here p raised to n, because we have taken y common and right hand side 5. This bracket what we have done, so it is a function of d, so I will write f of d of y is equal to phi of x, and I will say this as equation number 2. Fine. Now you can observe here, so this phi of x will vary, depends on the situation of the example. So we have two cases. So if this phi of x becomes 0, so such kind of equations are called homogeneous equations. And if this phi of x will not become 0, means not equal to 0, means it will take any other function of x, is called non-homogeneous equations. So in our syllabus we'll see both the kind of equation, homogeneous equation and non-homogeneous equations, and based on this, for this whatever differential equations we have, we'll going to find the solution of this, and we call as complete solution or general solution. Now we'll see how to write the complete solution or general solution here. So we'll see the complete solution and general solution for both homogeneous equation as well as non-homogeneous solution equations. So the complete solution is given by in short I'm writing C complete solution CS is equal to CF plus PI. What is this CF? CF is nothing but complementary function. PI is nothing but particular solution. If the equation our given differential equation is a function of y, then we can denote as YC and YP. Okay, so we'll discuss more about this in while solving the example. One note I want to say, so I told we have two kinds of differential equations, that is right now for homogeneous differential equation and non-homogeneous. For I will give in the form of note, the complete solution for homogeneous equation is given by, that is f of d of y is equal to 0, because here phi of x is what here 0. So for that, what we can say here, y, that is complete solution, is denoted by y is equal to CF or y is equal to C. Fine. And the complete solution for non-homogeneous equation is given by f of d of y is equal to phi of x, because phi of x will take any value here. Phi of x will take what here? Any value. At that time, y is given as what here? CF plus PI, or we can say y is equal to YC plus P, because in non-homogeneous differential equation, what will get here? Both your complementary function as well as particular integral, both it will come.